Welcome! In this video I will try to explain, to be more precise, how does a CNN, a convolutional neural network, work. So CNNs are the basis for most vision applications, and I'm gonna explain it using a really brilliant website, not by my design, regretfully. And first I'm gonna draw a number, because this CNN, this convolutional neural network, is made to recognize numbers, digits. So what you see here is my input layer, and what you see at the end is indeed it recognized a 4. So that's pretty cool. So what do we see in a neural network, in a convolutional neural network? Well, the first layer, this layer, is the convolution layer. That's also what you can see here. Here you see the input layer, then you see the convolution layer. This is the first layer. And what you see is that apparently, when you look at the connection, it's not fully connected, right? And it seems like that there's like a rectangle of, I think, something like 5 by 5. And that gives, in the end, the value of this new node or neuron. Aha! And again for this one, again for this one. But apparently it does something strange, because this picture is totally different than this picture. And that's true. What's happening here is convolution. So convolution is a kind of a math trick. It works with a kernel, and I'll explain convolution pretty soon. So this is six different convolutions, and the convolution is the same. It's always a 5 by 5 convolution, but the kernels are different. I'll explain in using a different website how that works. I'm gonna go to the next layer. The next layer is a pooling layer or downsampling layer. So that's this layer. This is actually a pretty simple layer, and it just downsamples the previous layer. So it reduces the resolution, right? It halves it in both directions. Okay, pretty simple. Then we got the next step, and that's again a convolution layer, which is kind of exciting, because it's convoluting multiple of the previous images into one image. And you can see that it's different for the different parts of that next convolution layer. So that's kind of exciting. Then we get again a downsampling or pooling layer. And then we get to our conventional neural network. Basically, this is just a fully connected layer, as you can see. So each of these neurons is connected to all of the neurons from this layer. And also for the next layer, and you see, okay, it's connected to all of the neurons of the previous layer. This results in the output layer, and the output layer is pretty effective, as you can see, because, well, it's clearly for what I've written. Drawn. So let's see if I do a 3. Oh, that's pretty good. Let's see if I do a 2. Let's do something like this. Oh, it still says it's a 2. But it also said it was a little bit a 7. Did you see? So here it was saying, well, it's a little bit 7. It's a little bit grayed out. Okay, so basically this top part is just normal neural network, and the bottom part is convolution, and that's kind of exciting. So how does convolution work? Let's go to the next website. Again, brilliant website, again not designed by me, regretfully. So how does convolution work? This is the input image, and here on the bottom, that's the left part of this one. That's the input image. And on the right, that's the result of the convolution operation. Again, what you see is that apparently one pixel on the right is now, apparently the kernel is 3 by 3, is dependent on 9 values of the pixels on the left, as you can see. How does this work? Well, it works with a kernel. So this is a sharpening kernel, and it's basically just 3 by 3 or 5 by 5 or 7 by 7, etc. An amount of numbers. 0, -1, 0, -1, 5, -1, 0, -1, 0. And those numbers are multiplied by the gray values of the image to the left. And that's something you can see here as well, right? You can see here that these are the gray values of that image on the left, and then multiplied by 0, -1, 0, -1, 5, etc. And that gives a new value, and that's the value you see in the picture on the right. By choosing these numbers, we can get all kinds of different operation. And this was a sharpening one. If we take, for instance, blur, so these are smooth values, you see that we blur the image. What we could also do is sharpen it in one specific direction. And now you see already that it kind of resembles those first filters in the CNN, which we saw before. Here, left Sobel, yeah. Identity, quite boring. That's a 1, so it's just the same as the previous image. We could do outline, -1, -1, 8. Similar to sharpening, but a little bit different. So this is convolution and a convolution filter. So when we get back to our layer here, this first layer is just what I explained. So here you've got a certain kernel, here you've got a certain kernel, here and here. Then you would maybe wonder, but how do we choose those kernels, right? Because that's kind of important. The neat thing is that the network, when it's trained, it's training the kernel values as well. So that 0, -1, 0, -1, 5, -1. That could be totally different in this case. And it's just trained by the network. So that's pretty cool. Let's try one last one. Let's see. That's a nasty 7. And I would say, well, maybe I make it a 2, and then it gets a 2. So it works amazingly good. It's the standard within Vision. And I hope this gives an idea of how CNNs work. Bye bye.